Hi there. Thanks for joining us today. I have your resume here, and I see you have about a year of professional experience working with Angular. We are looking for someone who has a solid grasp of the fundamentals, but is also eager to grow. How are you doing today?
I'm doing great, thank you for having me. I'm really excited to talk about my experience and see if I would be a good fit for your team.
Glad to hear it. Let us jump right in. I like to start with the basics just to get a feel for how you think about the framework. In your own words, what is the basic purpose of an Angular component?
Sure. From my experience, the basic purpose of an Angular component is to act as a self-contained building block of the user interface. It is essentially a way to encapsulate a specific piece of the UI. A component combines three main things: a template for the layout, which is the HTML, a class to handle the logic and data, which is the TypeScript, and styles for the appearance, usually in CSS. By breaking a page into these small, manageable components, we can handle complex applications more easily. Plus, it makes the code much more reusable because I can take a component I built for one part of the app and just drop it into another section without rewriting everything.
That is a clear explanation. Now, when you are actually building these components, you probably use the CLI. Can you walk me through how you create a new component using the Angular CLI and what actually happens behind the scenes when you run that command?
Right, so to create a new component, I use the command line by typing generate component followed by the name I want to give the component. For example, if I wanted a user profile component, I would type ng generate component user profile. What I find really helpful is that this command is a shortcut. It automatically creates four essential files for me: the TypeScript class for the logic, the HTML file for the view, the CSS file for styling, and a testing file for unit tests. But the most important part for me when I first started was realizing that it also automatically declares the component in the appropriate module. That means the application recognizes it immediately, and I do not have to go into the app module and manually write the registration code, which saves time and prevents typos.
Exactly. It handles the boilerplate for you. Now, once you have your component and you are working on the template, you often need to display data from your TypeScript class. I want to touch on data binding. Could you explain what interpolation is in Angular templates?
Yes, interpolation is basically the way we display dynamic data from the TypeScript class onto the HTML template. It uses those double curly braces, like double curly braces, variable name, double curly braces. When Angular sees that, it knows to evaluate the code inside, whether it is a simple string variable or even a function call, and then render that result as text in the browser. The best part is that it is reactive. So if the value of that variable changes in the component logic, Angular automatically updates the view to show the new value without me having to manually manipulate the DOM.
Speaking of the template, we also have property binding. How would you describe the difference between using interpolation and using property binding, like the bracket syntax?
That is a good question. Interpolation is primarily used to display data as text inside your HTML tags. Because it converts everything into a string, it is perfect for things like headings or paragraphs. Property binding, which uses the square brackets, is different because it is used to set the value of a specific property of an HTML element or another component. The big advantage of property binding is that it allows us to pass non-string values. For example, if I have a boolean for a disabled state on a button, I cannot really use interpolation for that because I need to pass a true or false value, not the word true or false as a string. Property binding lets me pass that boolean or even a whole object directly to the property.
That is a key distinction. Let us move into directives. You will probably use structural directives every day. What exactly is a structural directive?
A structural directive is a special type of directive in Angular that changes the layout of the DOM by adding or removing elements entirely. This is different from attribute directives, which only change the appearance or behavior of an existing element, like changing a color or hiding it with CSS. Structural directives actually shape the HTML structure. You can always recognize them because they start with an asterisk, like the asterisk ngIf or asterisk ngFor. That asterisk is basically a signal to Angular that it needs to treat the element as a template that can be conditionally rendered or repeated.
Right. And since you mentioned ngIf and ngFor, those are the two most common ones. Can you explain the difference between the two and perhaps a common challenge you face when trying to use both on the same element?
Sure. So ngIf is used for conditional rendering. It simply checks a condition, and if it is true, the element stays in the DOM. If it is false, Angular removes it completely. ngFor is for looping. It takes a list of items and repeats that piece of HTML for every single item in the collection. Now the challenge comes when you want to do both. Angular actually does not allow you to put more than one structural directive on the same HTML tag. If you try to put an ngIf and an ngFor on the same div, it will throw an error. To get around this, I usually wrap the ngFor inside an ngIf to make sure the list actually exists before trying to loop through it. Or if I do not want to add extra divs to my page and mess up my CSS, I use the ng container. It lets me handle the logic but doesn't render an actual element in the final HTML.
Using ng container is definitely the professional way to handle that. Now let us talk about the organization of the app. What is the purpose of the ngModule decorator?
The ngModule decorator is used to define a module in Angular, and its main purpose is to act as a container. It organizes a related group of components, directives, pipes, and services. It essentially tells Angular which parts of the application belong together and which components should be visible to other modules. For me, this is really helpful for managing dependencies. It also enables some of the more advanced features like lazy loading, where we can tell Angular to only load a specific module when the user actually navigates to that part of the app, which really helps with the initial loading time.
Let us shift gears to services. In a basic sense, what is a service in Angular, and why would we use one instead of just putting all the logic in the component?
A service is basically a special class that holds business logic, data, or functions that need to be shared across multiple components. If I put all my logic inside a component, that logic is trapped there. If another component needs the same functionality, I would have to copy and paste the code, which is a nightmare for maintenance. By putting that logic in a service, I can reuse it anywhere. Typically, I use services for things like fetching data from an API, handling user authentication, or managing a global state. This keeps the components lean and focused only on how the page looks and behaves, while the service handles the heavy lifting.
And how do you actually make that service accessible throughout your application?
To make it accessible everywhere, I provide it at the root level. I do this by adding the provided in property with the value root inside the service decorator. When I do that, Angular creates a single instance of the service that is shared across all components and services. This is the singleton pattern. It is really important because it ensures that if component A updates a piece of data in the service, component B sees that same update because they are both talking to the exact same instance.
That leads us perfectly into dependency injection. Could you define what DI is in the context of Angular for me?
Dependency injection is a design pattern where a class asks for the tool or services it needs from an external source rather than creating those tools itself. In plain JavaScript, I might use the new keyword to instantiate a service inside a component. But in Angular, I just tell Angular which service I need by adding it to the constructor. Angular then finds the correct instance and provides it to the component. This makes the code much more modular and significantly easier to test because I can easily swap out a real service for a mock service during testing.
Let us imagine a scenario. You have component A and component B. They are siblings, meaning they share a parent but aren't parent and child themselves. If component A needs to send some data to component B, what is the recommended architectural approach?
Since they are siblings, they cannot talk directly. The recommended approach is to use a shared service to act as a middleman. Component A would send the data or trigger an event in the service, and component B would be listening for that change. To make this work in real time, I would typically use a behavior subject or an observable within the service. Component B subscribes to that observable, so as soon as the service receives an update from component A, it pushes that update to component B automatically.
You mentioned BehaviorSubject. This brings us to RxJS, which can be a bit overwhelming for developers starting out. Can you discuss the differences between a standard subject, a behavior subject, and a replay subject? When would you choose one over the others in a service?
RxJS is definitely a learning curve. The main difference between these three is how they handle the history of emitted values. A standard subject is like a live broadcast. If you subscribe late, you miss everything that happened before you joined. I would use a standard subject for one-time events that do not need a history, like a button click or a notification alert. A behavior subject is more like a state variable. It requires an initial value and always gives the most recent value to any new subscriber immediately. I use this for application state, like the current user's profile or a theme setting, where the component needs to know the current value as soon as it loads. Then there is the replay subject, which is like a DVR recording. It can store a specific number of previous values and play them back to any new subscriber. I would use this if the sequence of a few recent actions is important for the new subscriber to understand the context of what just happened.
That is a very solid explanation of the RxJS subjects. Now, while those are powerful, managing state across multiple services can get messy. Could you talk about potential deadlocks or circular dependencies that can arise when using RxJS to manage state across interconnected services?
Yeah, circular dependencies are a real headache. It happens when service A depends on service B, but service B also depends on service A. When you add RxJS state management into the mix, you can hit a deadlock. This happens if both services are waiting for a value from the other before they can emit their own state. For example, if service A cannot initialize its internal state until it receives a signal from service B, and service B is waiting for a signal from service at the start, the application just freezes or fails to load. I have seen this happen most often when people put too much logic in the constructor or use synchronous operators that force an immediate value. It creates a loop where neither service can complete its setup, so the rest of the app never gets the data it needs.
Have you encountered that in your projects? How did you solve it?
I did encounter something similar in a project a few months ago. We had an auth service and a user preferences service that were calling each other in their constructors. To fix it, I had to rethink the flow. I moved the shared logic into a third, more basic service that both of them could depend on, which broke the circular link. Also started using more asynchronous patterns and avoided doing heavy initialization inside the constructor moving it to an init method instead.
Good strategy. Let us move on to forms. Angular provides two main ways to handle user input. Which modules are essential for this, and what is the difference between the two approaches?
To handle forms, you need to import either the Forms module or the Reactive Forms module. The choice depends on the approach. Forms module is for template-driven forms. In this approach, most of the logic, like validation and tracking, stays in the HTML template. It is quicker to set up for very simple forms. Reactive Forms module is for reactive forms, where the logic and validation are managed in the TypeScript component class. I personally prefer reactive forms because they are much more robust. They provide better scalability, and they are way easier to unit test because you can test the form logic without actually rendering the DOM. Also, because reactive forms are based on observable streams, you can use RxJS operators to react to every single keystroke in real time.
You mentioned the Forms module specifically. In the context of a component, what is the primary role of that module?
The primary role of the Forms module is to provide the tools for handling user input, and most importantly, it enables two-way data binding. This is where ngModule comes in. It allows any change the user makes in an input field to be immediately updated in the TypeScript logic, and conversely, any change in the logic is immediately reflected in the input field. It also helps track the state of the form, like whether a field is valid or if the user has touched the field yet.
Let us talk about the component lifecycle. There are several hooks, but which one is called when a component's data is initialized, and why not just use the constructor?
That would be the ngOnInit lifecycle hook. Now, the constructor is definitely called first because that is how JavaScript classes work, but the constructor is really just for basic class instantiation and dependency injection. ngOnInit is the best place for initialization logic because it runs after Angular has finished setting up the input properties. If I try to access a value passed from a parent component in the constructor, it will be undefined. But in ngOnInit, I can be sure that the input properties are available and ready to use.
Perfect. Now, as applications grow, performance can become an issue. If you were working on a very large Angular application, how would you optimize change detection performance?
That is a big topic, but the most effective way is to change the change detection strategy. By default, Angular checks every single component whenever any event happens, which can be very expensive in a large app. I would move to the on-push change detection strategy. This tells Angular to only check a component if its inputs change, or if an event specifically triggers it inside that component. To make on-push work effectively, I would use the async pipe in the templates to handle observables as they integrate perfectly together. For high-frequency events, like a window scroll or a mouse move, I would use ngZone run outside Angular. This prevents the entire application from re-rendering every single time a pixel is scrolled. And finally, when using ngFor for large lists, I would always implement a track by function. That way, Angular only updates the specific item that changed instead of recreating the entire list of DOM elements.
You clearly have a good handle on the performance side. Let us talk about something a bit more advanced. If you were tasked with designing a highly reusable component library module for a whole company, how would you ensure proper encapsulation and versioning?
That sounds like a challenging project. First, would separate the library from the main application using a monorepo tool like NX or Angular CLI workspaces. This keeps the library independent. To ensure proper encapsulation, I would be very strict with the public API surface area. I would use the public API TS file to explicitly define exactly which components and services are exported. Anything not exported stays private, so developers using the library cannot accidentally depend on internal logic that might change. For the look and feel, I would implement a design system using CSS custom properties. This allows the consuming app to override the theme and colors without having to touch the library code itself. As for versioning, I would use semantic versioning. I would integrate a tool like conventional commits so that version bumps are automated based on the commit messages. That way, if there is a breaking change, it is clearly marked as a major version bump, and the teams using the library know they need to be careful when updating.
I like that approach, especially the mention of a public API file to prevent leaking internal logic. Let us wrap things up with a few quick ones. You mentioned track by earlier for performance. In the context of structural directives, how does that fit into the way ngFor works?
Right, so by default, when the data in an ngFor list changes, Angular might not know which specific item changed, so it often removes all the DOM elements and re-renders the whole list. Track by allows me to give Angular a unique identifier for each item, like an ID. When the list updates, Angular compares the IDs and only updates the specific DOM element that actually changed. It makes the UI feel much smoother and reduces the load on the browser.
Great. Last question. Imagine you are stuck on a bug related to a service not updating a component. What is your process for debugging that?
First, I would check if the service is actually a singleton. I would verify that it is provided in root and not provided again inside the component decorator, because providing it in the component creates a new instance, which would explain why the data is not syncing. If that is not the issue, I would put some console logs or use the debugger in the service to see if the value is actually being emitted. If it is, I would check the component to make sure the subscription is active and that I am not accidentally unsubscribing too early. If I am using the async pipe, I would check if the observable is actually returning a value. Usually, it is either a scoping issue with the service instance or a missing subscription.
That is a very practical approach to debugging. I think we have covered a lot of ground today. You have a strong grasp of the fundamentals and you are thinking about the right things regarding performance and architecture. Do you have any questions for me about the role or the team?
I do. I am curious about how your team handles code reviews and if you have a specific set of style guides you follow for Angular, or if you use something like the official Angular style guide.
We follow the official Angular style guide very closely, but we also have some internal standards for RxJS usage to keep things consistent. Our code reviews are quite thorough. We focus not just on whether the code works, but on whether it is maintainable and follows the on-push strategy where possible. We really value clean, readable code.
That sounds great. I really enjoy following a structured style guide. It makes it much easier to jump into a new code base.
Definitely. Well, it was a pleasure talking with you. We will be finishing up our first round of interviews this week, and we should get back to you by Tuesday regarding the next steps.
Thank you so much for your time. I look forward to hearing from you.
You are welcome. Have a great day.